All right. Hello, everybody. Sorry about the slight delay there. Thanks for coming in. Today we have a couple special things for you. Some other members have brought some gear in for you guys to check out as well. First off, my name is Thomas, Kilo Hotel 6, Golf. I am a general, looking to get my extra, still taking my time with that part. But I am the president, and yeah, I'm here to help guide everybody. Why don't we go around the room and introduce ourselves? Sorry, we don't have a microphone and PA set up yet. We're going to have everybody speak up. If you're Portuguese, that helps. You can actually just belt it out. We want the whole neighborhood to hear you. But for now, we at least have a mic set up for the online community to join in. Hopefully, you can hear them as well. I promise one of these days we'll have a dedicated PA, as was promised. Yeah, so soon enough we'll have something better to go off of. It's all a work in progress. But I'm going to go ahead and start this off. Start off back here. Here you go. No, don't mind my cobbled together mic there.
That's kind of cool. All right.
Oh, wait.
I'm Tom, WH6EBS Extra.
I'm Bill, ND0B.
I'm Kyle, WH6FQQ.
Mark Watanabe, WH6FSA. I'm also a member of the board, and I have a silent auction item set up on the end of the table there. It's concealed over there, and it's an ARRL end-fed half-wave kit. I stress kit. And I'm going to sweeten that by saying that whoever picks it up, I'll donate that to the BIARC Club Treasury. So that silent auction closes at 3 p.m.
I'm Sharon, WH6ELV, and I am a general.
I'm Dennis, WH6ELY, and I'm an extra class.
Yeah, I don't know. I'm not from the Philippines, but I can talk loud. Les K0BAD.
Hi, Jim, WH6EMN. Just another announcement today. I kind of did a little something to the club library. I copied the covers of the books, so it's a little better to look at than just a list of books. So if you folks are interested, you can look through this. If you want to get a book to look and let me know what you want, and I'll bring it to the next meeting.
Excellent. Thank you, sir. I'm David, KH6CZ, and I'm responsible for the glitch in the communications here. I wandered off to the men's room and with my phone in my pocket, and we're using it as the hotspot today. So, sorry, my apologies.
Well, our whole meeting is the whole way they're actually connecting with us is through his hotspot. So thank you.
Tony Kitchen, WH6DVI, BIARC Treasurer this year again. And I did want to mention a little bit of clarification on the audio visual setup. When people online speak, it comes through the speaker here, the main speaker on the TV, and it's pretty loud, but I am interested, especially people in the back of the room, especially if you might not hear so well. I'm interested to know when people ask questions on the video that are participating remotely, if everybody hears. So I'm sure we'll get some questions from the remote crowd, and I want to make sure everyone hears, because if not, the TV is currently turned up to its maximum volume. It is pretty loud, but if it's not good enough, that means we need to buy external amplifier or external speaker.
We have an external speaker that was donated last month. Don't know where it is.
Neither do I.
It's that speaker, not the little one that I gave you.
Oh, larger one.
No, I have it. It's in my truck. I'm not there today, Les.
Oh, but I'm just saying, we don't need to buy anything right now.
We might need an amplifier.
I might have one. I might have at least a 25-watt amplifier.
See me? Hello, I'm Sean. I don't know if you can see me, but you can hear me. I am on the board, and I am WA6GXZ General. There I am. Hello, there I am. And I am going to be with these guys talking about Meshtastic later. But yep, good to be here. Hope you guys online were here. See all our toys. It's pretty cool. Okay, that's all I'm going to say.
Hello, Luke McKay, WH6GRW Amateur Extra, and yeah, you'll hear lots from me again soon. So
here we go. Looks like home. WH6 EPS Amateur Extra, covering the Mountain View area. That's my, I guess that's my stomping ground up there. Having fun today with the digital. We stuck a lot of stuff out on the table, so hopefully everyone will take some time later and get a good look at that after Luke's presentation. So thank you. Over to Hank.
Thank you. This almost looks like I should brush my teeth with it or something. I'm Hank, KH6HAK, amateur extra, space cadet, part-time lightning rod, and whatever. Learning Meshtastic. Thanks to Gary, I've got a couple of little Meshtastic nodes programmed here and hoping to get online soon. As soon as my solar panel comes in, that's the last piece I'm waiting for.
Right. Hopefully your solar panel makes it soon, and hopefully you don't have to pay anything extra when it gets here. All right. Well, shoot. I mean, was there anything, any announcements from education and outreach or anything to that effect, or?
Well, I'll say that I'm William, NH6ET. I'm joining online today. Sorry, I couldn't be there in person. I'm the trustee of the club's call sign, KH6EJ, and I hold a position on the board.
Thank you, William. And Joe, did we get introduced?
No, my name is Joe, WH6JOE. I'm an amateur extra. I'm into all things radio and most. I'm the secretary of BIARC, chair of the Operating Activities Committee, and I'm looking forward to this presentation because I recently purchased and ordered a portable Meshtastic node. That's all I got.
Okay, thanks, Joe. And next over to Lee. Are you with us, Lee?
Unmute, Lee.
Can't hear you, Lee. We'll come back to you. We'll go on to Luke. Where's Luke? Oh, we did, Luke. Yeah. And EPS, we heard from Gary. Yeah. And I guess that's it. And yeah. Oh, you asked about the NOC. Yeah, next month we're going to be at the Hilo Union School down here, and we did the Kamana School last month. Very good event, and looking forward to continuing for the rest of the year with the same crew that is very, very, very outgoing. And thanks to Les for the new speaker we've got that works like a charm. And the foldouts, the flyers for the club. So very good. Back to you.
All right. Okay. Let's see. Were there any other announcements? I think that was it. Again, if you're in need of an NFED half-wave kit, and it is a kit, the silent auction form is over there. And yeah, it'll be done at 3 o'clock there. All right. Well, we can actually go into our program. Do you have things to set? You gonna share your screen and everything? Cool.
Thinking about it.
Slowly but surely. Oh,
We tried.
did she unmute?
Yeah.
Lee, can you unmute?
Oh, you mean Leah?
Lee.
She's looking at us.
Well, I think she might be having technical difficulty at the moment.
Okay.
Yeah, you're not coming through, Lee. still muted.
Lee, if you're on your computer, press your space bar.
Oh. Technical difficulties. Well, we can circle back there. Yeah, I'm gonna
Well,
go
let's
ahead and
introduce her. That's Lee Critchlow. She is the lovely instinct wench, as she puts it, who is the editor who produces the Buy Our Camgram, our fantastic newsletter. And she lives up in Mountain View area and is an active operator.
Thank you. All right. Well, let's go ahead and get this program started. Here you go. Look.
Excellent. Thank you very much, Thomas. Tony, a quick question on the screen. If you could make it a little bit bigger, maybe. I'm guessing nobody can read that from the back of the room, if that's possible.
Yay. Oops, I unpinned it. Keep it pinned. And let's see what we can do here.
Getting there. Oh, yeah, maybe that's, oh, no, not quite.
I'll try to figure it out. Go ahead and I'll play with it.
Okay, well, thanks, Tony. So again, my name is Luke McKay, WH6GRW, and I'm a fairly new ham. I've had my extra for, I guess, 2.5 years, and had a technician for about a year before that. So I'm not long in the hobby, but I am long in other hobbies related to it. So my day job, particularly, I'm an electronics engineer with UH. I support the 2.2 meter telescope up on Mauna Kea. So I'm neck deep in control systems and many decades of different control system equipment, electronics that have been installed up there. So RF, though, yeah, relatively new to me. So today I'll be giving a demo, some training. Before that, a brief introduction on Meshtastic. I'll be helped out by Sean here and by Gary. They can introduce themselves later, although you probably know them already. So what are we going to do? If I can advance my slides. Yes. It's going to take a second to update for everyone. So today's plan may be adapted, will be adapted. I've got some slides that are an introduction. What is Meshtastic? What have people done with it? What are some of the use cases and capabilities, apart from the examples I'll give of what people have done. Brief description of LoRa and CHIRP spread spectrum, which is hard for me to say, so I'll say CHIRP and not the rest. And then we're going to have these demos. I'll do the first couple, an Android app interface demo. I've got a simulator running on my laptop, so hopefully we can all kind of see that. If not, there'll be more hands-on later. And then a simulated, I just put ERT, emergency response team. So when I got here today, I took 5 minutes and set up a node and an antenna in the parking lot. That is step one of the simulated deployment. We'll go over some more of that later and show how this could be used in an emergency off-grid communication situation. I'm going to hand over to Sean. He's going to talk a little bit about some of the more IT stuff, I guess. Some of the interfaces with Linux, with Raspberry Pis, with Arden Mesh, some other options there. And then over to Gary, who's going to show some of the Windows, iPhone, and a variety of other things, interfaces. So we'll try to cover all the basics. We're not going to try to get too deep into it, but there is a chance that I'll go off the rails and start digging down on something. Just wave at me and, tell me to come back onto reality there. Plenty of time for hands-on testing, Q&A, and just, taking a look at the stuff we've got around here. So interrupt me with any questions. we'll start off with what is Meshtastic. So according to their website, it is a project to enable inexpensive LoRa radios to be used as long-range off-grid communications platforms. They say in areas without existing or reliable comms infrastructure. It works well even when there is that. There's not a lot of interference issues. It's a 100% community-driven and open source project. The Meshtastic, I'll put a trademark on some of these. I think I have the title slide. There is an organization that holds the trademark. And so if you see that name, it doesn't necessarily mean it was approved by them because it is a community and open source. So what does it do? When they say long range in that description, they're talking about decoding of messages down to -20 dB SNR. So that's similar to FT8. That's similar to some of these other modes that you might use on HF, but in something this big. So commodity hardware that makes that really cheap. Off-grid means you can use these small nodes. You don't need to rely on high power. You don't need the internet for it to work. There are some things that the internet can be used for that make it more useful. Inexpensive. So kind of build it yourself nodes. You can get the hardware for that for $10 or $15, the cheapest. Pre-built nodes comes with an enclosure. I think Gary's got one to show, and there's a couple others floating around. You can get for $40. It has everything you need to hook up to a smartphone. For that price, you don't get an interface. So you still need a computer, or you need a Bluetooth-enabled smartphone or tablet. So that's just for the radio and the microcontroller that runs the packet side. Now, this is a BIARC meeting, and so we're all hams, but you don't need to be a ham to use this. In fact, 99% of people using it are not using their ham privileges. So what we're doing today is all using the Part 15 ISM band license-free operation. So for us, that's 902 to 928. I'll show some maps of other people using this around the world. They're using 868 or maybe 433 unlicensed. And there are options to do 2.4 gig. So I haven't explored that much. There's not a lot of people building those because, this isn't really a high bandwidth endeavor. And so you lose range. So it's not really worth the extra effort to go to 2.4 gig. But if you get that hardware, you can use it without changing your frequency almost anywhere in the world, which is pretty cool. And what it does, it's an automatic mesh. So it enables this communication by just automatically setting up this managed flood routing. You don't have to worry about anything apart from, what's my channel, what's my frequency, what speed do I want to communicate at? We'll go over all that. And if you do that, then everything on the network just works. There's no addressing. Your device ID goes with you, but you can change the name of your device, and you don't have to worry about the details. Small networks and large networks may be more complicated. So small networks, you don't have enough nodes to connect. Large networks, you might have collisions and run into bandwidth problems, airwave utilization problems. But for medium-sized networks, which is, I'd say, 50 to a few hundred nodes, it should be pretty straightforward. This should just work. Here's just a little basic demo of showing a fully connected network, and then on the right-hand side is a partially connected network as a mesh. And I put this up here just to emphasize we're never going to have a fully connected network in the islands. Middle of Kansas, small town, you could have a fully connected mesh, a couple square miles with no terrain. We don't have that. We're always going to have a complicated diagram, partial mesh topology. So if anyone has questions about that, we can dig into it more. So what can you do with it? What have people done with it? State of the Mesh International. You can't read this very well probably, but this is from liamcottle.net. And so this is people that have volunteered to send their data, position data up to this website. And they're showing 5,000 people in Western Europe and Britain, a couple hundred in Eastern Europe, and then a couple thousand in the US scattered around. We've got other ones. So there's many, many thousands of people using this. This is probably 10% of the people that actually have these devices that are uploading to this service. There might be a couple nodes in Russia there. I think there's a Green 8, which is over there kind of by Ukraine. And I don't think that's Russia. I don't think Russia, China, and India are doing much with this. But if they are, maybe it's just that none of them can talk to this. Liam Cottle, where is he from? Is he British?
British.
He's in Britain. So maybe they just can't talk to his server.
Yeah.
So state of the mesh in the islands here. And so this first slide is what I call the RF mesh only. So this is my logging node snapshot from yesterday. My QTH in Volcano, I've got a Raspberry Pi with a tiny little antenna, and it hears traffic come down from repeaters we have up on Mauna Loa and up above the saddle on the Mauna Kea side. And so yesterday I was receiving 36 nodes in the half an hour before I took the snapshot, 40 nodes in the previous day or two. And there were 16 of those on Maui, 1 on Oahu, and the rest on the Big Island. And again, these are nodes that are volunteering their position on a public channel. There are other nodes that are out there that we can't see, but there's a mesh. It exists. We're using it to communicate. Here's from Sean's hawaiimeshmap.ddns.net. And so these are nodes, and this is a simplified view. Again, I didn't zoom in and show where all of these are, but these are nodes that are on the internet connected side of things and sharing a location. And you can see there's about 40 of those, or yeah, something like 40 of those.
Real fast. By noting this, you do not have to have your location logged with Meshtastic or anybody else. You can use a verbose location just in case, like APRS. You can actually set that you're just in Hilo or this side of the island. You're not dedicated to have the GPS turned on and constantly pinging your location. Just making sure you know.
Yeah, so thanks for bringing that up. So just as an aside, there are options for sharing your position or not. If you choose to share your position, you can do so at any precision level. So you can say, make it off by 5 miles. And it doesn't randomize, it just picks like a corner of a 5 mile square and will put you there. And so your position won't be seen to move around as you're moving around. So yeah, all sorts of configuration options there. And if you want to set up, I'll get into this a little later, but if you want to set up totally private communications, this is a way you can do it. So since I showed those maps, I'll say your map will vary. The maps that you see on a node vary in time based on who you're hearing and based on settings. So whether or not you're on the internet. If you choose to participate in this internet traffic, it may allow all traffic that goes through your node to be uploaded to anywhere on the internet unless specific settings are changed. So there, I want to emphasize that it's you're in control of the privacy and you can choose whether or not to participate in that. So many nodes are on private channels, and we'll get into a little bit of what channels are later. So you can choose to do that and not be visible. There are lots more nodes out there that don't have GPS or a hard-coded location. They won't show up on maps. And just a warning, locations can be spoofed. This is open source software. Anyone can go in there and say, here's where I am. Or I want to follow this route and pretend my node did this. So trust locations from nodes that you trust, if that makes sense. And even then, of course, you're at the limits of technology. So how far can you talk with these devices? Here's what's on the Meshtastic website. Ground-to-ground range tests. The current record, 331 kilometers or 205 miles. I believe this was that by the Baltic, by Martin R7 and Ali G. So anyway, this is 2 nodes, basically like this, but probably with a little stubby antenna on top of, 4,000 foot mountains, 205 miles apart. And they had a reliable link between them on about 1/8 of a watt broadcast power. Ground to air. Current air record is surprisingly only 206 kilometers or 128 miles. And these are some folks that posted their results of a balloon launch. So they had a node that went up in a balloon and they had reliable communications to it from a ground node 128 miles away. I think that's the record because you're not supposed to broadcast from commercial aircraft. So here's from 2 weeks ago. It's hard to see. I wonder if I can highlight this. I can come over and point. There's in the kind of upper right of the blue map, there's a node there. There's a little picture of a seal. You can use emojis as your name. So somebody found an emoji of a seal and put it in there. And so this is a screenshot from my phone a day or two ago, showing that on the 30th of January, this node was approximately 300 miles away and sending messages to me. So, you know, I've got on this slide 3 of the positions they reported. You won't be able to see it, but the altitude reported was 11,190 meters, 11,172. So GPS still works up there, but obviously, you know, commercial airliner. And the messages here say, the zoo, SEAL, has shared their position with you. This node lives near Monterey Bay. I looked on maps later and found that they are over there. So in any case, about 300 miles from a commercial aircraft back to Hilo, probably to our Mauna Loa node actually. But it's not a record. It's not official. It's not legal, technically. Yeah, you can get tons of range from small devices if you get up there. It's just line of sight. Yes, Hank.
His son was a skydiver back to Washington State. And he pulled one of these from a parachute and was getting 250-mile range from his skydive to the ground.
Excellent. Yeah, so range is easy, reliability is harder. So getting a node that you can trust, whether it's on a balloon or obviously you can't leave it up there long when you're skydiving, but you know, is bidirectional communication possible? That's where it's really important to do the range tests and see what you can get. So yeah, 300 miles isn't bad from somebody putting it in the window of the airplane. So apart from those types of shenanigans, can you move that up? I'm missing the title of the slide on this one now. Yeah, maybe just.
There we go.
Okay, so some use cases apart from those shenanigans. Public group messaging, and this is in quotes because it means different things to different people. So when you install your device, you'll have the option to configure channels. The default channel is quote unquote encrypted, but it's a widely known default key. So it's not secret, it's not private, it's not, you know, anything other than just a basic encoding so that if people don't want to see your messages, they don't have to. You can do that. You can set to no encryption at all. And if you ever want to use your ham privileges, you have to turn off all encryption. So it's not something people do often because it eliminates tons of the functionality here and you don't get much more range. You can only go to 10 watts because it spreads spectrum. So it's not really worth it. But if you do, remember, you're not going to have any encryption. You still need to share with people that you're going to communicate to. Those devices need to share a channel name and the basic radio configuration. We'll get into that later. You can do private group messaging, channels with a custom encryption key, easy to set. And then you can share that configuration and key as widely or as narrowly as you want. And finally, direct messaging. So by default, out of the box, there's a public key encryption, public key infrastructure encryption on these. So all direct messages from one node to another node, and again, so you can't do this in ham mode, are fully encrypted. No one can decrypt those. You do need to have had a communication with that node before for the handshake, for the keys to transfer. But once that setup is done, you can send DMs, and if they get it, no one else read it. So that's pretty cool. And one other use case I'll mention is remote sensing and the sharing of GPS location, et cetera. So if you plug sensors into these, by default, the GPS data and the sensor data will only be shared on the primary channel, the 0 channel, and not with all the channels you can set up. Like I said, you can choose how much to share, but by default, your GPS location is going to be fuzzed on that public channel. So you don't accidentally leak out, exactly when you're going to the bathroom or whatever. So that's useful. There are some environmental sensors supported automatically. So here's an example of what the Android app looks like with some of those sensors. I apologize, I'm using Celsius and pressure in millibars. So yeah, this was just a snapshot from yesterday on one of the nodes here in Hilo. Indoor air quality is the one on the bottom right. So a lot of these have particulate sensors or gas sensors that are useful for monitoring VOG, or Gary will tell you about fireplace.
Hey, Luke,
yes, Tony.
question on the sensors. Have you seen anyone playing with weather stations that would feed data? over this
Yes.
mesh?
So there's a ham over on Maui called Tavis. He has, I forget his call sign. He's in Antarctica right now. And in any case, he's got an ultrasonic wind sensor he uses. He's a windsurfer or kiteboarder, I forget what he does. In any case, yeah, so he has this at a remote location near where he would go out, and it just is constantly sending wind data up to the internet and to the nodes. So that's easy yeah, but it takes some extra effort. So it's been done. You can copy this, but there's no weather station you can just plug into one of these at the moment and have it work. You need to build an interface.
The data on the receive side, you'd need to set up your own software framework that can consume that. feed.
Presumably, yes. Yeah. So there's probably other ways of doing it. And your question was great because it did preempt my next slide here.
Oh, sorry.
Custom sensors are possible. And so that weather station would be one that's at least a semi-custom sensing option. But it takes some extra programming or extra hardware. So yeah, so Gary was mentioning the BME, the 680, the Bosch multi-environmental sensor. It's about a $20 sensor. You can get them cheaper, but $20 on a board with connectors. And that was where that air quality, temperature, humidity, pressure was coming from, was one of those sensors. And so those are easy. Those just work. You just plug them in and it works.
What about a motion sensor or a door sensor? Like say you want to get a text alert when someone walks onto your property or opens your front door.
Yeah, so for that kind of security or alarm use case, there's two different ways you can do it. One is the hardware has an option for general purpose IO. You can just put your security wire pins to this interface board and it's supposed to work. I haven't tested that, so I can't promise whether or not it does. There's another one, which if you have the right devices, which would be the more powerful microprocessors that have Bluetooth and Wi-Fi on board, you can set those up as kind of a, they call it a PAX counter. So you'd use this at an event or at a mall or store to see how many people are walking by. And so it's just watching for those Bluetooth IDs or Wi-Fi access points or anything that, any of that RF coming by, and it'll say, okay, I saw 20 people in the last half an hour or something like that. So at a remote location, that might be useful because if you see even one person, you can, have a question of why is somebody there? If it's not me, why is somebody there?
Then you can also count people like passing by and speaking to them.
Absolutely, yeah. And I'm sure it's customizable, but by default, that PAX counter setup does not identify people.
Right.
So it doesn't tell you, hey, I saw this ID yesterday. It just says, how many people have I seen in the last, 10 minutes, 15 minutes, half an hour, whatever you set it to.
So what would the hardware look like other than the sensor? The sensor would connect to what? An Arduino microcontroller with custom code or what?
So a lot of these, and Gary's got one just like this. It comes with You can take apart this sandwich of printed circuit boards and slot another one in that has a little quick connector. It's an I2C serial connector, and it has power, ground, and the serial ports. And there's hundreds of sensors that just plug into that. And I think about a dozen of them are supported by default on this software right now. So that's the easy mode.
Rack. Oh, I should talk on that, right? Rack is over there. Another very popular node that's developed. It has a sensor, an environmental sensor. You can see it right there. When we look at the table, very tiny, about $20. Does pretty much what you saw there on that screen. So it'll give you an idea how it runs. You also can load it up. Anybody wants to try the notes should download Meshtastic, just to let you know.
Yeah.
Just starting from the beginning, I was an early adopter, so I went with the cheapest, most affordable options because I'm a ham. I went with one of these, a Heltec V3, and it's hard to see from back there, but there are so many pins on the upper and lower edge of this. Two of the pins are used for power and ground for a vibration motor, so you know when you're getting a message or something to that effect. But you have all of these other user identifiable pins that you can attach, 40 of them literally, to attach your own sensors to and enable certain, even if it's just a simple on and off function, you can name that pin set and say, okay, this is going to be my vibration sensor or my notification for this going off. These two pins will be for a speaker. So you can have an audible sensor, a chirp coming out of the unit there. So there are options that, that don't even get brought up. As you go further, deeper into things, there are extras that you can add on to things. And there are companies that have added extra functions that you can just plug and play, like you were mentioning. One of them that's really popular is the Grove protocol, which is a 4-pin interface. It uses I2C. It goes a little bit deep into the weeds there, but once you see one of those sensors toted as having I2C, that means you can pretty much plug and play any sensor on that whole environment into that unit. So these are things to just think about. If there's something that you wanted to add on to something, it might be simple. You might just be able to plug, play, and hit yes. I want that to be functioning as doing this one thing. Just wanted to put it out there because it's one of those things that it kind of gets glossed over. Thank you.
So control systems, remote monitoring and control of the telescope is my day job. So I do this stuff a lot. Here's something I built, custom sensors. It's sitting in my yard up in Volcano right now. It's a 3-axis accelerometer hooked up to a Raspberry Pi, just baking that processor doing signals processing. But here's one of the charts that comes out of it, which is standard deviations of accelerations coming from it. So lots of things are possible if you're willing to plug in a Pi, do some programming in Python, that sort of thing. And then this is just the backhaul to get that data out. So there's, some custom database work and other things. Anything's possible if you're willing to spend a week programming. Yeah. Okay. We're going to get into more of the hands-on stuff, but I wanted to show of hands who here knows how LoRa chirp spread spectrum works. I can probably raise my hand. Okay, we've got one from William, I think. Was that William? So correct me, William, if I say anything that's patently wrong, please. Okay, LoRa, chirp spread spectrum. Now, some people will tell you chirp stands for compressed high intensity radar pulse, but I don't buy that. Not for a second. As a matter of fact, one of the websites where a bunch of my pictures will come from put that on his website, and I'm like, do I trust the rest of it now? This is not a radar pulse. Okay, the LoRa protocol allows you to choose range and noise rejection versus communication speed. So pretty typical. So without going into too many details, I hope. Just thinking about it. Just thinking about it. here are some chirps. Now this is rotated 90 degrees from how we normally see our waterfall displays. So time in milliseconds is on the bottom, going from 0 on the left to about 64 on the right. And those are various chirps. These are all 125 kilohertz wide, but they're different spreading factors, different noise tolerance, essentially. So you can see that one on the far left is just 2 milliseconds. So if you happen to get a little bit of noise in there, you've lost your bit. The one on the far right is 32 milliseconds. And so these are simulated graphs. I'm pretty sure that this website, this S. Guzlaya, I think he's an Indian guy, and I forget the first name now. It's a long first name that S stands for. In any case, I'm pretty sure this is MATLAB simulation code. So it's not going to look like it really came out of a radio because it didn't. So those are different chirp widths, and then these are the beginning of a LoRa packet, and then a few bits of data. So this is what it would look like if you could run your SDR fast enough to grab these off the air. So each one of those little chirps is a window. That time window, once you get past the preamble, will show you the bits. Very similar to something like FT8. This LoRa protocol is patented, owned by Semtech, which is, I forget where they were founded, but at least partial US ownership, widely licensed, but it is still proprietary. There's some boxes drawn around here showing 4 up chirps and then 2 down chirps. That is the preamble that says, hey, listen. So your receiver doesn't have to have a huge amount of processing power. It just needs to have an ASIC, an application-specific little bit of the hardware there that's watching for those. And once it sees those, it knows, oh, this is the frequency you're on. This is how fast you're going. I'm going to start listening for bits. And on this picture, the 4 starting to be broken up chirps on the other side are the bits, and they're different. They're not bits, they're symbols. Should have jumped in and corrected me, William. So depending on what your spread factor is, you have a different number of symbols. Here's what it looks like decoded. What happens on the receive side, you decode it by basically multiplying whatever you receive with a down chirp. So if you receive a perfect up chirp, like those 4 preamble chirps were, flip back to that slide real quick here. Those first 4 preamble chirps are up chirps that start at 0, your base frequency on the left, and go up to your maximum frequency on the right. If you combine those the right way with a perfect down chirp, you get nothing. That dark blue is minus 140 dB. Then you have the 2 down chirps. If you combine those, it's just like the whole thing is high signal. After that, when the chirp has that discontinuity between the top and the bottom, basically will tell you what symbol it is. So you combine those 2 and you end up with a straight line by combining the up chirp and the down chirp. And where that line is with respect to your center frequency determines what symbol you've got. So I said I wasn't going to go into too much detail. That's as much detail as I know. So don't ask me anymore. William can jump in maybe, or somebody else that knows more about that protocol if necessary. So.
Oh, you nailed it spot on.
Okay, great.
From a simplistic view, the advantage of chirp is that it plays well in the noise. Yeah. So when you think of the noise as a ham, what does that mean to you guys? You know, you're hearing them, but this is the advantage. This is where LoRa really shines. Somewhere between minus 20 to 140 or 140 something is the noise. And that's where the chirp signal cuts through that noise. So I won't go much further than that.
Yeah, so just what happens if there's a noise spike halfway through one of those symbols is you'll have a discontinuity in that horizontal line. So the receiver is going to be trying to get as much of that clean as possible. And if it can't get all of it, it'll say, oh, well, I think that was it. So you also send some extra symbols once in a while to kind of, make up for some that might go missing. But if you have a really slow increasing tone, which is that chirp, and you have a discontinuity, this algorithm is just fine. It'll decode it, no trouble. So that's how you get to 20 decibels below the noise floor on receive with this particular method. Obviously not the only one, but works pretty well on this cheap hardware. Just briefly, because the symbol rate and the spreading factor that determines how slowly you're sending affects your bit rate. So effective bit rate on the long fast, so-called long fast preset that we use is like 1 kilobit per second, maybe. So that's the protocol's effective bit rate. Your device is going to have to share that because of the flood routing. So it's a couple hundred bits per second. It's text speeds. It's not audio. It's not pictures. All that stuff is theoretically possible with LoRa radios. Don't waste your time on it. It's not going to do what you want. There's better ways to do that. Yep. Okay, so I want to show you the Android interface real quick. But before I do that, are there any other questions? Go ahead, Gary.
I just want to get a quick survey of the room. We have Windows users, iPhone users, Android users, Linux users. Start with iPhone. Anyone can get a raise of hands? Okay. And then Android. Okay, about equal. We'll go Windows next. Our Windows users. Okay, about equal. And then Raspberry Pi Linux users. Okay, so it looks like a good even mix of the room, actually.
We got to cover everything.
Oh, we forgot Mac.
Yeah, Mac users, BOS, Amiga. Sorry. Who's using OpenBSD on their daily workstation? Okay, so I'm going to share. We'll start with Android because that's what I had on my list. And I will share my Android emulator running on my laptop here. Maybe. It's coming up. Okay, so I wonder if we can zoom in on that one. I'd switch to landscape mode, but I never use this interface in landscape mode, so I don't know how well that's going to work. Okay, yeah, so Gary's iPhone demo is going to look similar. It's going to be, the aspect ratio of a device.
Yeah, it doesn't have a zoom option on this.
Okay. I'll keep this short and sweet then, and we can get on to more hands-on stuff later if people want to poke at buttons. And like Sean said, if you want to download the Meshtastic app on whatever your device is and try connecting it to one of the nodes we have here later, feel free to do that. Although if you download it now, you might take all my bandwidth. So we'll take a little break in a few minutes. Okay, so.
Found the zoom.
Okay, so this is going to tie into the next demo, which is what I call the ERT deployment demo. And specifically, I'm simulating the volcano emergency response team since I'm a part of that. And I think I want to try to use this if we have emergencies up there. But it does not imply that anybody else at VERT approves of my demo here. And this is not an official thing yet. So this is the Android interface. Start it from a disconnected state. And how do you connect? Well, most people will be using Bluetooth. So you'll click on this little plus button on the bottom right that you can't quite see. I'm sorry, Tony. Maybe we can't zoom in. And now my emulator is going to search for Bluetooth devices, which it's not going to find because the emulator does not support Bluetooth pass-through. So I'll give up on that and say, well, I just happen to have a node here, which is sharing my Wi-Fi. I'll connect to that one. Normally when you connect to Bluetooth, and Gary can show you this, it'll ask a PIN if it's not a configured node. And either the device, if it has a screen, will show you the pin to put in, or if it doesn't have a screen, you'll put in 1, 2, 3, 4, 5, 6, and then it'll be connected. And then you can change that setting if you want, so other people have a little bit harder time hacking it. But here's the interface. So the one that's most interesting is this vert channel, which is like the chat room. Gary, can you send some messages? Some of us have this vert channel on our devices and some don't. I think Gary's got it. Paul, I think you've got it. So as messages start getting sent, you'll hear beeps and rattles and shakes. And so the screens on these aren't that useful, but feel free to take a look and then pass those around. You'll hear a beep when the messages come in. There are a few buttons on these. They have GPS. So all of these functions are exposed in this interface here. Yeah, go ahead, Gary.
The speed of this, so I'm going to go ahead and hit the send. You'll hear the beeps come in. It's usually about a second or two, and then to maybe get them out, it's about 5 seconds. So there goes. That's pretty fast on the transmission rate.
Yeah, short message, and it's bouncing around the room here. So yeah. 906.875 megahertz is the frequency we're on, which is the default kind of US frequency for this speed mode. And even though it's an emulator, it is connected to a real device. That didn't work. Okay, so I sent a message out. It's hard to see from where you are, but there's a little cloud here on the bottom right. So there's a timestamp and a little cloud. When I hit send, that cloud came in empty. And then as soon as my node right here heard some other device rebroadcast that packet for it, it said check. So if your node sends out a message, if it's on a chat channel, a public channel like this, or a group channel like this, there's no acknowledgement sent back. That's just as a waste of bandwidth for the most part. So what happens instead is the managed flood routing, the mesh network, my device will listen for some other device to forward that packet on. And if it hears that packet get sent by one other node, it says job done. If it doesn't hear that, it'll retry a few times before it gives up. That doesn't mean nobody else heard it. It means I didn't hear anybody else repeating it. So there's some nuance there. And a lot of times in a questionable area, you'll send out a message. Your message will go out, but you won't know it went out. So no acknowledgement, even though it says acknowledgement. Gary, put a test in your message if you're going to say send support. No, it's okay. Nobody else is listening to this. It doesn't matter. For the current presenter, is that what you mean? Or? Okay, so that's a chat on channel. So you can also go into the node list here. And the current node that I'm connected to is the one on top. I've called this vert comms. It's actually behind you, Gary, over there. It's the one plugged into the wall. So it's a little Heltec V3 like Thomas was showing, and there's some more we can look at over there later with a 3 dBi antenna on the side. I have it strapped to a little USB hub because I was going to bring a Mac in and plug it into that, and it turns out that USB hub is broken, so I just plugged it into the wall. So that's vert comms. I set the name on it. You can see it says 94% battery, if you can see that there. It's not on battery, it's just plugged into the wall, so that doesn't always mean everything. And then there's some other nodes here. So this top one, A55C. Second one down, it's kind of a tan on the left there, A55C. So yeah, that's Gary right there. My node says it's receiving with an SNR of 6.5 dB. and an RSSI, a signal strength received of -44 dBm, which is excellent. Of course, they're 6 feet away from each other with only Gary in between. So it says signal good. There's green bars. If you notice the one underneath that, which is called LM base, that's my home base node. And it says it's 34 kilometers away. It says it's 5 hops away. So we are connected to it right now. Packets we're sending in this room are getting up there. But it's not direct. So I don't have a signal strength indicator on there because I'm not hearing that node directly. It's hopping through this circuitous path that's going from my house over to Halepohaku, just below the radio frequency prohibited zone on Mauna Kea. From there back to Mauna Loa, from there back to probably Jim's node, or maybe directly to this node we've got out here. So yeah, it's a long route, but the mesh is working. There's a few other nodes in here. I'll send a direct message to somebody. I don't know who's got VERT02, VE02 node, but I'm going to click on that node and send a direct message. This is exactly the same as sending the group message, except for the encryption. So actually, let me go back one step.
None of us will be able to hear device to device.
More accurately, all your devices will hear the packet. They just won't be able to decode it. I didn't send it yet. I don't know who that was. Yeah.
A direct message, well, it is a direct message, requires a certain amount of variability in it. And then say if it's RF, you SNR and RSSI. You've got to have a good connection. Otherwise, it will fail.
More often.
In use cases. Now, UK has done this considerably more than most countries. And why they've even moved off of
Meshtastic over to Mesh Sense or some other thing is because there is a certain amount of unreliability in this. When you got good reliable, it's just like us hams know of. When you got good RF, you're going to have reliability. What level that is, what's reliable RF is the question for maybe these guys.
Yeah.
Engineers and whatnot.
Packets will be dropped. First rule of networking, especially mesh networking, packets will be dropped. So the cool thing with direct messages, there's a good chance they will go through. There's a lower chance you will get a confirmation, but there is a mechanism for you to receive a message back from the node you send it to. If you can see the bottom of the screen there, I'm sending hello direct to the VERT02 node. Oops, enter doesn't work there. I hit that button. This one will be straight. It'll be straight through. What you might see on the node list sometimes, or even on the screen, is it'll have a stale hop count. So it'll say, oh, it's 3 hops away. Because it hasn't updated yet, it doesn't realize that it just received a direct. It could also be because we've got multiple nodes out there that are routing traffic in the parking lot. The whole mesh just could be meshed up. Yeah. That's my first one. I've been holding back. So in the bottom right of this direct message, you'll see a little, I don't know, avatar trying to look like a head and shoulders of somebody with a check mark next to it. My hovering isn't working. Let me try sending a direct message to a node that won't work, and we'll see what looks different. I don't have any nodes in my list that won't work.
Yeah, good. I tell you, good RF will give you reliability. Me and Luke, they had an RF up the volcano, and I always had it. I get trace route, I get direct message. Now, since we have a complicated geography, like Luke said earlier, what point of level of saturation, is going to be doable for us,
Okay, so I just sent 2 direct messages to my base node in Volcano. Because it's 5 hops away, that node is only set to 3 hops as a limit, because I don't direct message anybody from that node, so I don't care how far its messages go out, just that it forwards things on. So I didn't hear a response back. So I see a cloud with a check, just like I saw on the group message. It says somebody rebroadcast that for you. Great. But if you look at this one that I sent to the node that's in the same room, we will see that it has that check mark with the person there. It's saying the node I sent it to responded back and said got it. So that is a full two-way handshake that was completed. I know that my message was received.
Certain times of the night we've noticed propagation. Even during the day, it comes in spurts right now. We're getting propagation to Maui and Honolulu, and I was able to hold a direct message conversation with someone off island. So it can be possible. It's very unreliable at this point due to the elevation of our nodes, the particular setup, the testing we're doing. As each node goes up, we'll look at improving that on both islands and trying to establish that path and establish that path to Kona. So that's one of the goals. But it did work. So we have been getting messages, group messages back and forth, and some individual direct messages with acknowledgements.
So before I move off of the kind of Android app demo and the basic use here, I'm just going to show you the configuration options. So there's options here: user, channels, device, position, power settings, network, so you can hook up to Wi-Fi. Display options for these devices that have the little OLED display. You can change how that functions a little bit. The LoRa radio settings, whether or not you have Bluetooth, and then security options. I'm not going to go into detail on this. None of you really care. Once you get devices, you'll want to know all of those. But the basics, go into the user here, node ID. You set a node name. I did vert-comms, and then a short name, which is 4 bytes. You can use an emoji there, but some emojis take 4 bytes, then you only get 1 character or one emoji. So you can set the name of the device that way. You can go into the device settings here, and you can say what role is the device. So this will be the first and last technical aside that I'll do on the configuration, because I'm going to wrap up here soon and hand over to the other folks here. Device role is what part of that mesh are you? Are you a dead end? Are you a mountaintop repeater? Are you trying to do a specific function? Like, I just want to have this device on my car and know where it goes, but I'm not sending messages. So the device role can be client, which is just typical mesh node. It will rebroadcast traffic, but it's not going to try that hard. You can do client mute, which says, I really am just an end user device. I'm not going to rebroadcast traffic for anyone else. I'll just talk on my own behalf. Router, which is rebroadcast everything. Not recommended to be used, surprisingly. Because of the flood networking, router nodes just stomp on everybody else's traffic. So the client node will say, oh, I heard something. Should I repeat it? Let me listen for a second. Yeah, okay, I'll go ahead and repeat it. The router will say, oh, I heard something. Bam. So if you can barely hear somebody and you're a router, you're going to repeat all their traffic. They might not be able to hear you. Other nodes might not be able to hear you. So they're going to start rebroadcasting on their own, and there's going to be collisions. So router and repeater modes are typically not recommended. We have some that are set. I don't know if this list even has it. Nope, it doesn't. There's a router late, which is I will rebroadcast everything, but I'm going to wait until everyone else is done talking first. So we've set some to that. But for the most part, we don't use those because a client will rebroadcast. There's a tracker role. So for a GPS tracker that you want to have really good battery life and you're not interactively using all the time, you set it for that, and it just sends out its position however often you configure and saves the battery otherwise. The other ones are kind of obscure sensor TAC or ATAC nodes for tactical tracking. Might interest some people, but you don't need to use that mode to do that functionality. Client hidden is basically like a client, but you're not going to broadcast your node ID. You're trying to lay low. I don't see that it has a good use case. And I don't know anything about lost and found or TAC tracker. And then there's one more, that router late that I mentioned, which isn't in this interface. So yeah, that's a really important setting, not to change, but to just not get wrong. So if you just go with the default client, for the most part, you're good. For those of us, 3 of us here at least, that might have half a dozen nodes, turned on at our house at any one time, we use that client mute a lot. And that helps the reliability of the mesh because these handheld devices aren't repeating then. So yeah, that's an important setting. And then I'll just show the LoRa settings. Maybe if people are interested, Gary can go into more detail on this. Defaults are fine. Just use the defaults. So use a modem preset, long, fast, no frequency offsets. You can change the hop limit, which is set to 4 on this device right now. Unless you buy a node that has an amplifier, you don't need to touch the TX power setting. And then frequency slot and the other settings, just go with the defaults. One minor exception is you might want to do what I've done here, which is deselect at the bottom this OK to MQTT, which is OK to put all my traffic on the internet. And in my specific case, I also click the button that says ignore messages that came from the internet. So you don't have to do that, but those are good options to know where they live. So with that, I'm going to go back to my slide deck real quick and just show for my simulated emergency response team deployment. I'll show you, because I kind of just did that, passing the devices around and stuff. But I will show you what I actually set up out there in the parking lot to make that work. And then I'll be done. I've gone over time already. You guys got to keep me on task. Yeah, so let me just show these photos and then we'll do the auction in a break. Okay. My apologies, my network connection is becoming slower with time. Oh, okay.
Might have to plug in your phone there too. I didn't even think about that. Let's see. Spare battery here. Just in case. Keep things going. I've got it plugged. Oh, you have one of those.
So I use wireless charging.
We'll skip that part. It's not that interesting. We can actually, if you're interested later, you can take a look at the 10-foot aluminum pole over there with 6 dB antenna on it and a little 20-watt solar panel on the ground. That is the base command center for this simulated kind of emergency response team. And you can take that anywhere and it'll get probably 5 days of battery life, or it's got that solar panel. Just set it up, hand out these nodes to anybody, train them how to use it. But if you just want to track them, you don't even need to do that. Just make sure the little GPS switch is on this specific model and you're good to go. You have text communications for whatever group and position tracking. So the real benefit to my mind of that is you don't have to say, hey, are you a ham? Hey, do you know what frequencies we're on? These are relatively cheap devices. You pre-program them and just hand them out. And that allows, I think, a really interesting expansion of communications in that type of disaster recovery situation or emergency response situation. So, and because it's a mesh network, the more you have, the more robust that communications will be. So you can really spread things out if the need continues. So, excellent. Time for a break.
Take I'll try to make one out of this one. I don't know if we're going to keep it around. Oh, yeah. All right, we kind of went past the 15-minute break there, but I think we have just one more leg of this to go. So if we could get your attention, and let's see. Did everybody get a chance to take a look at the gear? Because some pretty interesting stuff. Considering it's all cobbled together too, that's the best part. And you don't necessarily need a kit from one specific thing. Yeah, you know, like that's good. And that's one of the basic kits too. Like that's that one that Luke just had in his hand there. That's literally one of these, and it comes with that little plastic enclosure. I chose to not use that plastic enclosure for mine, but that doesn't mean you don't have to or use something in particular.
Before we move on, Thomas, could I figure out who has the other one of these notes?
I can take it on.
There we go.
I mean,
they're not samples.
It comes with a built-in GPS tracker and changeable IDs. Very easier things to steal.
Okay.
Ryan, Gary, who's on? I could do so quick because you're kind of important. I'm just going to mention Linux and if you can.
Yeah.
There's a mixed group. So, okay, you guys, this is going to be really quick. I'm going to be that other conversation about RF and the alternative to RF, which is the internet, which I like to think of as linked connections too. In the absence of RF, there is what is known as the MQTT. Not too long ago, I didn't know what that was, but it's just a server somewhere. It can be on a Pi in your home. It can be public or private. What I'm going to cover is just private, really quick. MQTT is public, and as you guys noticed it, and the man over here mentioned, ignore it really from the start. Turn it off. Not okay to MQTT, bro, as they say, the bash heads. And you know, by default, it won't be configured. So when you get your Meshtastic device and then you just turn it on, you don't do anything to it, it's going to be in default. And anybody who's in default on that channel, which is the primary channel, you'll see them if they have the RF. When you go into configuring the MQTT, that's when you go into different realm. You configure the MQTT per channel, uplink, downlink. You allow that to happen. What I'm going to say briefly, because what he showed you today was Liam's map. Me and Tavis, God, I did have his name. Tavis is me and him put together a private node in Hawaii Mesh Map. If you guys are interested, I'll give you the URL. And that has a private MQTT broker. And that only runs for those who are configured for a specific channel, specific cache, which is the public, in order to be on the map. He showed you Liam's map earlier. If you're not configured to that, you're not going to show up. That's the idea. There is a thing, as I think mentioned earlier, that there's a bit of RF overspill. So you have somebody on the MQTT like me, and I have this RF-rich node. It seems to be, right, that now you may not be on the MQTT, but all of a sudden you're showing up on my map. So there's some anomalies. And as such, because part of that, when you look at this, if you're into internet at all, broadcasting is just blurring out all these names and nodes and information, telemetry, where are you, what's the temperature there, and oxygen and blah, blah, blah. And it's noisy. Managed broadcast is really kind of silly. If you look at MeshSense, when you look at this, you'll see the telemetry information just constantly going. Even if no one's chatting, Meshtastic is talkative. That's the RF. That's how it works. That's how we communicate with each other. And is that a level of communication and saying, hey, are you out there? What's your SNR? How good is your RF? Oh, you don't have it? Oh, do you have the MQTT? So that would be in the absence thereof of RF, being a complex geography, we have the MQTT. What I have learned, because I run both, is in the absence thereof, when I have good RF, I've got the RF. And when it's good enough, I get a direct connection. Boom, 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 every time. Good traces, good direct connect. When it's not there, or it's dubious, or the propagation, as we know, because propagation varies, right, at the time of the day. Sometimes we're hitting Maui, other times we're not. If we want consistency, where do we get that? We can go crazy with the RF, which we want to do, to get a consistent of how far are we going to go, where we're going to say, we got that Williams style RF. We're going to know it's there. It's solid, you know. So that's where potentially the internet could come in. The argument of the internet too could be in satellites. We can use Arden. There's an Arden. If you guys want to look at that, I'm just not going to go into that much. But we can tie in internet to the Arden, run through the Arden network, or we can just use it as a router. Like this is just set up in a router and RF. This is not on the internet, but I could make it on the internet, and then I could say tie it into a dish and run a dish from one dish to another. See the possibilities? Linked connections. I know RF is our goal as hams, but there's more to life than just RF too. We all look at those devices in our hands. What are the ones we carry around? We're not going to forget that PDA or that phone. We're going to, you know, it's over our wallet, right? So I think that's part of why made Meshtastic work too, because people are used to messaging, text messages. It's there, it's in the apps there. Even when the phone's not on the internet, it works with Meshtastic because it's RF. So this is a Pi 4 with a hat that is made by one of the developers. It's attached there. I have an extra one if anyone's ever interested in using it. Linux native is relatively new. It's been around. It was used as a simulation device I won't go into that, but it used to be for simulation. And then recently, a guy named John came in as one of the lead developers and picked up on it. And Meshtastic D has been coming alive for several months now. And it's really coming into its own. It runs on a browser. It doesn't have to. There's other ways to run it. And one of the greatest things about this for us is the administration capabilities. Because one of the things we struggle with right now is how to do that. That can be done through what is called as a CLI command, which is Python. It's a CLI. Meshtastic builds a derivative of Python. That's all I'm going to say. And it's used to be able to send information, commands to remote devices. As today, as far as I'm aware, you guys can verify this, that kind of administration, say like updating software, is really quirky. So some of us are hoping that Linux is, you know, and that IP variable is going to give us the opportunity to do that kind of work, to manage larger networks. And there's a lot of development going on about this, because since Meshtastic, as we're approaching it, is not ham radio, but it's the Internet of Things, there's a lot of development going on about it. So I think what I say real quick, right here, this is a rack mode over here, RAK. This is one of probably the lowest power devices, great for solar, been around for a while, a lot of modularity. That's got an environmental device on its 20. These are T114s, version 2s. These are the latest and greatest boards from Heltec. That's a Rockland board. That looks like a mesh stick. That looks like a mesh stick too. This is Spec 5. Spec 5 is custom kind of turnkey stuff. Thank you, Kyle, for bringing this over. This stuff is really cool because, again, what a lot of is happening in Meshtastic is developers are on board on this. They're building all kinds of solutions. So some of the things you guys know about, like the LilyGo, T-Law, that one there. Does that look familiar to some of you guys? Back.
A BlackBerry.
BlackBerry. Yeah. So That is really popular. So it's an all-in-one device, similar to like the G2 Ultras. So there's a variety of ways to approach this. Any one of these things too can be running from a Pi USB to those nodes, and then you can run it off of Python and other things. So the extensibility, that's what I want to point out, of things, and the applications that can be built around it. Sensors, BBS, mail, alerts. So there you go. There's a quickie for you. Over to Gary.
All right, thanks, Sean. WH6 EPS here. So I guess we're down to the final two subjects. I'm not sure who's still online. I can't see the screen there. Tony, can I make myself the presenter real fast?
Yeah, go ahead.
Who's online and who's still awake? That's the question.
I only see Lee, so Lee's the only one. Only one I see
Mike
there.
Walters online. We got William online.
Okay, and I'm going to apologize. I'm going to share my entire screen, and it's might get a little confusing, but we'll see here.
That's the best way to go, Gary, because it lets you
Not with my desktop.
tab around to wherever you want.
Okay, let's see if does that come up?
It's slow. Give it a minute.
Yes, no, yes, no.
For 5 seconds.
Okay. Anyway, so I guess today, just in recap here, it's not connecting.
Did you click the screen and then click the share button at the lower right?
Yeah, it says stop sharing. So. Oh, did it? We'll try one more time. If not, it'll be a real short presentation.
I needed to unpin, I think.
There we go. Okay, so present now. Entire screen. Share. Okay, unfortunately, it's not going to let me.
Why? What did it say?
It just says stop sharing, and then nothing is coming up.
So while we're working on that, I just want to mention Gary has threatened already.
Yeah.
That we might do more advanced, deep dive on some aspects of this.
Stop sharing. Let's do it.
So if anyone's interested in that, please, let us know.
Now you got to click
If anyone thinks that's the worst possible way to spend your time.
Starting there is curved and screen sharing. Let's try it again.
I guess I might as well
Let's try
say, too,
it.
like,
Let's try an
once a
app
month,
real
I
fast.
started a net on All-Star with Point All-Star Network. We're working together to try to bring up the net, state all wide and whatnot. We talk about Meshtastic then, we're just trying to tell anybody. And it's not like it's
I've never seen that.
questions that
Okay,
we're
one
just trying to
more
bring them out
time,
there
and
and
then if
see
not,
what we
then
can
we'll
do to it, or like look into it. Anybody heard of TO?
I bet
On
it's
YouTube.
the fact that you're using.
This is character. What they do is just sit down and solve a problem together in real time. And from that, you kind of learn how to solve that problem or how they went about their methodology.
No, it's not. My computer's not liking.
So some of what the monthly net
Guess we
meetings
can't
at
share.
the roundtable is to kind of promote that kind of thing. And that's how hopefully, as a group, we'll all learn how to develop Meshtastic for us.
Okay, unfortunately, the Google Meets is not liking my computer. We did test this on Zoom a couple weeks ago during our training, and it went out okay. So I'm not sure what's happening with Google Meet. So this will make it very short. I'm using a program, an application called MeshSense. I don't know if you'll be able to see the laptop, and I apologize for the people online. I'm not going to go into any real detail with this. Some of you might have walked past it. So at home, I need a way to access this. I don't want to have my phone with me all the time if I'm sitting at the desk, or maybe I leave something in the other room. I keep this on one of my monitors on the home computer. I think Jim's using it in his office too. It's a little easier on the eyes than trying to look at the phone all the time. It'll show all the open nodes, so you're able to see who's connected. It'll show the trace routes. It'll give a map and kind of show how the nodes are connecting between each other. It has a little message function in the bottom, and then it shows you all the traffic that's going across the mesh. I think we can get in this another day when we're able to show this across the screen, or get into this at one of the tech nets, or if anyone wants to use this, it is available on Windows, Mac, and Linux, this particular program.
And they have to be 64-bit ones. I tried it at home on my 32-bit machine. So you need the latest, greatest computers. What was the name of the app?
It's called MeshSense.
Sense.
Like the sense. So it does not allow you to program a node. It allows you to more operate the node, view the information, the statistics. If I hover across the top, I'm going to see weather data from Mauna Loa. I'm going to see the sensor data that's coming in. I'm going to see all the traffic in the bottom window. If that's too much, I showed Jim how to show messages only. It's a little checkbox at the bottom. That'll clean the screen up and only see messages that are coming into the channel. So very easy, user-friendly. There's some other options in there. I send this out to my Fire TV stick, and I'm actually able to use the keyboard on my Fire TV stick to send messages from the living room TV. I can send it in the picture-in-picture. So it's kind of a fun little app to play with.
Hey, Gary, is
Yes.
that map that's showing on your screen part of the app? Or is that-
Yes. So that's part of the app, and we can zoom right down into where the nodes we are, where we're at. If I can get my mouse to.
That map's being generated from HIP node.
Right, but it would have the real-time data of everyone on the channel
Yeah. So you can,
that has GPS enabled.
or has set their position. There's a lot of nodes in here that have not set their position. There's over 100 and some nodes I pick up from Maui, and I did not clear the database out for today. So there's a lot of nodes in here that this device has connected to. The other thing I wanted to go over, so that was MeshSense, is the iPhone app. Unfortunately, I'm not going to be able to get the iPhone app up on the screen today. That's another primary way I use to program my node. I find it very, very easy to send messages. Yesterday we went to the Hamfest and had several miles between us as we were driving back, and we were able to send messages between the vehicles. And at that time, when we were driving across the high road, we were bouncing off Maui, coming back to Mauna Loa, hitting the HPKU Halipahaku node, and then heading to Volcano. So we were ricocheting like a zipper back and forth to get our.
Miles, a few miles on the ground. This is the thing you keep in mind. What the algorithm does is it looks for the furthest node with the lowest signal first.
So
And then from there, well,
I will stay around for a few minutes if anyone wants to come and take a look at the iPhone app, or if anyone wants to do a demo. Unfortunately, today with the technology not working properly, I can't display that on for the Google Meet. Also, if anyone wants to do online for the TechNet, or do any type of one-on-one configuration when their nodes come in, willing to do that for firmware upgrades and getting nodes programmed for the primary channel and getting you online. So I think we did a few firmware upgrades today before the meeting. And if you want to make arrangements with me before the next meetings, if anyone quickly orders anything, we can get that programmed. Has anyone figured out how to turn them off so when you're at dinner, the wife's not? Luke, you want to come back up and then we'll wrap things up?
Sure. Any questions, concerns, comments other than Jim had one? So maybe this needs to continue. So maybe you're right, Gary.
I just.
Joe, is that you?
Yeah. Yes.
Yeah, go ahead.
Okay, so it says here that MeshSense can be connected to your Meshtastic node via Bluetooth or Wi-Fi. My question is, can you have your mesh sense and your on your Windows computer and your Android Meshtastic app both connected to your node at the same time?
The answer is no. So unfortunately, the solution to that is to spend another $20 to $50 and get another node. So there's no way to have multiple client devices like cell phones or laptops hooked up to the same radio. It just, they step all over each other. It doesn't work. So
Wrong idea. No way to do that then.
not on any devices that I've seen.
So when you were talking about multiple devices, you were talking about one node connecting to another node.
That's right.
No, but I can elaborate on this a little bit, guys. There's a thing called meshing around, a bot.
It's called meshing around. It's a bot, and it allows you to connect multiple nodes to that, but they have to be independent nodes.
Yeah, that's multiple nodes
Yeah.
for one computer.
Yeah, running on a Raspberry Pi. So you can run up to 9 nodes on that Pi. And meshing around, me and Spud Gunman have been working to, I've been helping him break his hardware software. And it was so, and that will has a BBS, a mail, alerts, and all kinds of other stuff. So
Earlier I said I use it from the Amazon Fire Stick. Over the past year or so, since I had 2 internet outages that lasted more than 5 days, I've tried to get everything around the house to work without internet connection, and that includes the Fire Sticks. So what I was able to do is with MeshSense, it's got a built-in server, and you can just go in there and check a box. That's all you need to do. And then any computer in the house, any tablet, Fire Stick, anything that's still on your personal network, you can have as many connections back to the mesh as you want. It serves up a web page that you can operate from one room or operate from another room. So where that could be useful in a disaster preparedness, let's say you had it on the CERT container and you have one person sitting there monitoring messages, you could have another person over here doing documentation on their tablet to the same node that's sitting on the tower. So that could be, another way to use it. And, or let's say if it's at the hospital, the node is sitting out in the trailer, it backhauls on the hospital internal network, and someone on each floor could be looking at the messages coming in at the nurse's station or down in security or somewhere else. So the single instance of MeshSense could be shared out across the private network.
So that being, I just got to make a brag on Doug. Gary there. Gary, the Arden Mesh, we both kind of mentioned this, but he got it on there first. He ran MeshSense on Arden on the HAP. Do you know how on the Arden the HAP you can create a link? Most of you guys have, I know Paul has one. You can just link MeshSense like he did. Right. So I can go and he has to set it up where I can access it. He did, I think, at the RMS gateway. So, here, because I wanted to mention that because that was super cool. I can go onto his node and text to it.
So a lot of people were using, I don't want to confuse the topics here, but a lot of people were using the Arden mesh, not the Meshtastic, the Arden mesh. What I had did is under my Arden mesh node, so WH6 EPS, I put a link to MeshSense. So if you go in there and click MeshSense under the tunnel network, you'll get a interface that will allow you to type your message out and come out on the RF MeshSense. And then vice versa, if we're sending RF messages and you want to kind of explore this a little bit, you can log into that tunnel network and interact with us. The only thing I ask you to do is just put your call sign in. And then if you want to test coverage or see if something's working from your house, you could go back and forth. So it's going to come out from Mountain View.
Yeah,
it's
cool.
Yeah, so that is, Tony, to what you were saying, it is possible with a server in between.
Yeah, right.
That's what I was mentioning. Yeah. So thanks for that, guys.
So the MeshSense in that case on the Arden, it was actually running on the HAP.
No, I did not go down that. Well,
where is the software running?
It's running on my WinLink server.
This runs on a HAP.
MeshSense is installed on my WinLink. So the device plugs into the USB cable from the radio to the WinLink server, and then the WinLink server network is plugged into that.
So it's running on a Windows computer, basically.
Running on Windows.
Yeah.
Okay.
And you can also run MeshSense on a Pi, but it takes a lot more work. If anyone's curious, I did it.
I just spend $50 and get another node. Anyway, yeah, cool stuff. And I also, I don't mean to denigrate that because I also have my own private database logging stuff and, doing all sorts of complicated things on Linux. So,
And he has Grafana.
yeah,
Anyone heard
custom
about
graphs,
Grafana? That's another way
custom
to
maps where
stuff.
you can download the maps in advance and have it completely offline. So you don't need to rely on a network for the background of the map to load, for instance. All sorts of stuff you can do if you're going to set it up. I didn't have that ready to demo today, so maybe next time. Okay, I think we're over time and we'll wrap things up unless there's anything urgent. Thomas, do you have any closing remarks?
Well, any questions about what you've seen today? Hopefully it actually pokes at you folks and makes you interested in the next part of it. I didn't see any glazed over eyes and nobody was snoring, so that's a good sign. We'll probably delve deeper into this when we have a little bit more material to produce and hopefully no technological glitches when trying to present it. But this was a pretty good run. I want to thank you guys for bringing all the gear in. Thank God there's more people on this network than just me. It's been about a year and I thought I was alone. So very happy that more people have gotten involved. These guys have jumped way farther ahead than I am though. So there's that. But yeah, I want to thank you guys for coming. Sorry I went over just a little bit here, but we're going to go ahead and close on up. And yeah, I look forward to seeing you at the next meeting.